Hi, Lori MacVittie back again. If you forgot, I'm a distinguished engineer and chief evangelist with F5, and I have brought Ken Arora on to talk about one of the items on our app delivery top 10 list. Ken, introduce yourself to the folks.
Hi, folks. I'm Ken Arora. I'm also with the Office of CTO, distinguished engineer, and for a fair bit of my time at F5, a product architect as well. So happy to be here.
Ken's got his fingers in everything. He's kind of one of my go-to folks when I have questions, especially about security and stuff, because he knows it really well. And today I wanted to talk to him about ADC05, which is unoptimized traffic steering, which sounds really right complex and crazy, but Ken's going to break it down for us right here. So, why is this a challenge for organizations delivering applications and APIs?
Well, come on, Lori. Don't you want your traffic to be steered optimally?
Well, yes, of course, but what does that mean? And why would an ADC, right, help with that? So start with like why? Why do we need to optimize traffic steering? What is it and why do we need to optimize it? Go.
So yeah, I mean that's fair. I mean the world has evolved a lot since the beginning, the early days of ADC, and those days, it was like okay, just kind of get my traffic there, and maybe I worry about bandwidth because we were on our slow dial-up lines. And today, we have lots of bandwidth. We have bandwidth hog applications, but we also have latency hogging latency sensitive applications. Like your autonomous vehicles. We have what I call maybe less a kind of geeky term, but jitter sensitive things that don't care about latency so much. They just care that latency is consistent. And that's like audio, right? Your audio can be delayed half a second as long as it doesn't jump around. That's one angle of, not the only angle, but an angle of unoptimized. It's like you need to optimize for your app. Does that make sense?
Yeah, yeah. You're saying if it's jitter sensitive, you need to optimize for jitter, and if it's bandwidth, constrained, then you got to deal with that, right? You have to optimize per the type of application that's going
Yeah.
on. So,
Yeah.
what if we don't? What happens if we don't? Let's ignore it.
Well, I mean, then, so you've spent, if you being, a large enterprise has probably spent tens of millions of dollars, maybe more in building, buying network gear and switches and compute servers and NAS arrays and all these things. And they they want them. So unoptimized means you're not getting your best return on your investment. I mean, ultimately it boils down to dollars. I spent $100 million a year on let's say purchasing and maintaining the stuff. If I get 10% improvement in efficiency, that's $10 million right there. Or I can serve 10% more customers, and that might make a 20 or 30% impact on the bottom line. So it's the bottom line. I'll throw out one more thing, which is really important in the world of Gen AI, which is Gen AI. The budgets are immense, right? $1 billion for how many NVIDIA boxes on one of these NVIDIA data centers. And I talked about delivery, but delivery includes sending things to the right compute server. And if you don't do a good job at that, you can cost yourself hundreds of millions of dollars. More concretely, if you have an unoptimized traffic steering algorithm or load steering algorithm that just says, okay, I've got a whole rack of GPUs and I'm going to send it round robin. And a metric is how hot is the hottest GPU, the most busy GPU versus the least busy. If there's a difference there of say 35%, in other words, some GPU is running 95%, it's really going, and because of the way the round robin or whatever algorithms are going, and then the least busy one's at 60%, you're wasting a lot of time. If I can instead, and maybe my average is like 75, 80%, if I get to a better load balancing algorithm that keeps everything at 90 or 95% consistently, I have now for my compute bound Gen AI app, I have I have increased my efficiency. I just bought 20% more GPUs. That's pretty cool.
That is, and I think, and now I think it becomes clear, really, when we're saying unoptimized traffic steering, it's really about distribution of load, whether it's global or local or like hyper local, right? Within a specific cluster. So load balancing algorithms become very, very important to optimizing your traffic steering. Yes?
Yeah, totally, totally. And I love the fact that you're taking this global view of it. It isn't just what you're doing on this one load balancer sitting at the edge of your data center. It's everything. It is maybe edge computing to say, what do I send to an edge? Maybe using GSLB or some other technology. It might be potentially even at some point saying, what am I actually going to do to the client? I might have a WASM thing running in the client, and you're making intelligent decisions about where to do work and where to steer a request. Some requests can get handled on the client. Some of them have to go to the big data center. Some of them, and those could be for compute reasons. They could be for governance, which is another topic. But there are all these reasons. So yeah, totally.
Absolutely. And I love how you keep dissing on round robin, because anyone who's known me for the last 20 years or so knows that, like, I would remove the ability to do round robin because it's the most inefficient. I mean, it works, but it's the most inefficient algorithm on the planet. So, hey, watching you, go out and check if there's round robin right now in any of your ADCs anywhere, right? There's probably a better way to do it. So go out and check that now. And we have to actually go because we're almost out of time. But I'm going to bring Ken back again. Yes, again, because I love talking to him. And we'll talk about another item on the ADC list a little later. So until then, bye.
All right. Thank you, Lori.